For this project, we used reverse engineering to recreate an Apex car that was provided to our team. Each component was designed using the software Creo Parametric. We followed the concept that the engineers of the local motors team used for the design of the Strati. This was to create a single piece for the cover and printing it using additive manufacturing. For this project, our team got the following objectives: recreate the Apex car by using reverse engineering, redesign the body of the Apex car into a more aerodynamic version to get a faster product, and by following the Strati concept, print the body, redesign, and substitute the original in order to race it against our classmates.
Our plan to work on this project has the next steps. First, we start disassembling the parts of the car in order to get the measurements and create the solid drawing of each part. At the same time, we label the parts with the corresponding code in order to have a control and to distribute the work. Once the parts were distributed, everyone made the design of each piece using the Creo Parametric software. Finally, we assembled the components that everyone worked on. The final step was to 3D print the body as one piece, having as a reference the Strati car.
During the first week, we covered the front suspension system. All components are important in any mechanism, but in suspension system, the shock absorber, the steering system, and tires are remarkable components. The tire. The pressure on tire works to absorb the impact. The suspension is a very important part because it receives all shocks in case there are irregularities in the road. The front section includes the steering system, which allows the car to turn left and right, the shock absorber, a mechanism that moves up and down while receiving the shock.
For week 2, we proceeded to work on the rear part of the car. In contrast to the front suspension, the rear suspension is designed more rigid since the wheels do not have as much movement. The differential is a group of components that provide the speed and the rotation of the wheels. It is connected to the drive shaft to use its rotation. The differential contains a main gear, which guides the rotation movement to the outdrives, which also guide the movement to the wheels.
The mechanism in the differential allows left and right wheels to turn at different RPM. The power from the engine is transferred to the ring gear through a pinion gear. The ring gear is connected to a spider gear, which we can consider as the heart of the differential. For week 3, we work in the chassis and assembly. The chassis support the load of the body, engine, gearbox, steering system, and shaft. It also provides structural integrity, which prevents the car from collapsing into itself under large amounts of strain.
Once all the components were designed, we proceed to assemble them together to obtain our final product. This contains the recreation of all the systems and major parts that our Apex car had. The systems recreated were the rear and front suspension that included the shocks and tires, the differential, the chassis, and the shaft.
Of a project, we faced with some difficulties. The first one is that among the components from the Apex car, there were some really small pieces which were tough to disassemble. To draw the 3D designs, we needed the Creo parametric software, which is only available in 3 school laboratories, all of them with strict schedules to which we try to adapt. We are a diverse team. Some of the members have worked and one even lives in Reynosa, so it was very challenging to come up with a schedule where everyone could meet.
This project was really helpful to develop our skills on Creo parametric, as we spent a lot of time on the design of the components and systems that our Apex car had.
We also work with the time efficiency. With this we mean that we have everything before the due date, we distribute the work evenly, and we also work with the lab schedule.
Regarding the car, we learn a lot of things about it, because even we use a car all the time, there are several aspects we don't know about the functioning of a car. Obviously, there are some difference between a car moved by a combustion motor and the radio control Apex car. For example, the suspension system of the Apex car is too close to a real car. Also, the steering system and the tires. The differential is a little different, but generally it works the same.
As a conclusion of this project, we were able to replicate the design of the components and systems of the Apex car that was provided to our team into a Creo parametric assembly file. In addition, we were able to redesign the cover provided into a more lightweight and aerodynamic version of it by having the Baja racing car as a reference. Finally, we were able to 3D print the cover as one piece using the Strari project as a reference.